Okay, we're going to try to go through these notes on this video really quickly so we can work on problems in class. I know it's hard to read from the video, but keep your notes open, and you can probably tell where we are just by kind of keeping up with the diagrams. An angle, so this is angle. An angle is a figure formed by two rays or sides with a common endpoint called the vertex. So in this little blank here, the word vertex goes. It's going to be hard for me to blow this up. I'll try to blow it a little bit bigger in a minute, but let's see what we can get on this page. Okay, so the vertex here is A. We can name the angle several ways. Okay, so you can name it by its vertex. Let's just look at that next diagram there. You can call this angle R, and that's already on your sheet. You can name it by a point on each ray in the vertex. Basically, it's saying you can name this. If you notice these two that they tell you are okay here on your paper, the vertex has to be in the middle. You have to go SRT or TRS, but you might want to write vertex has to be in the middle. If you're going to name it with three letters, has to be in the middle. Okay. You can also name it by a number. For instance, they marked this one angle 1, so I like it when it's marked like that because, naming it with three letters is a very accurate way of doing it, and sometimes we're going to have to do that. It's kind of nice when they put in like a 1 down there so we know that that's angle 1. Okay. Okay, so if you're going on down, the set of all points between the sides of the angle is the interior. They're just talking about the inside of the angle is the interior, and you can see it labeled on that picture above this on your paper. The exterior is the points outside the angle. Okay, so they've colored the exterior kind of a gray outside, and the interior is a lighter color, and they've labeled it there. You cannot name an angle just by its vertex if it's the vertex of more than one angle. For instance, if I say angle Y here, would we be talking about this angle here, or would we be talking about this one? We don't know. That's why sometimes we have to use three letters. In a case like this, you have to use three letters to name this, okay? So, for instance, here we would have an angle, the red angle, we could name it either WYZ or ZYW. Notice that vertex Y is in the middle. And then the blue angle here, we would have to name it XYW is one way, or the other way we can name it is WYX. Either way is correct. You just pick one unless it tells you to name all the ways you can do that. So let's look at the problem down below. It says a surveyor recorded the angles formed by a transit point, point A, so we're talking about point A, and three distant points B and C. Name three of the angles. Okay, well I'll use color and do each one separately. Here's one. I could name that BAC or CAB. I'm just going to write one down. I'm just going to call that BAC. Let's do a green one now. This one right here that's green, I can name that angle CAD or DAC, either way, but because A is the vertex, it has to be in the middle. And notice on both the blue and the green angle, A is in the middle when we named it. And then there's one last angle here, and it's the big angle, the overall angle right here that I'm doing in purple. And we could name that one angle BAD or DAB. Again, notice, it's supposed to be D there. Notice that, man, it's not picking up. This is supposed to be BAD. Purple one is BAD or DAB. Okay. Again, all of these have A in the middle, and we would have to use three letters to name each one of these different colored angles that I drew, because you wouldn't know which angle we were talking about if we just said angle A. You're like, well, which angle A? There's three of them there. Okay, number 2 says write the different ways you can name the angles in the diagram. It's kind of hard to read here. If you look at the angle marked angle 1, you can name it angle 1. You can name it angle OTR, or you could name it angle ROT. All of those would be correct. We could not say, though, OTR or RTO. Not the T has to be in the middle. We couldn't say, though, angle T, because you'd be like, well, which angle T, right? So now for angle 2, which I'll pick green to do it in. Here's angle 2 here. You call it angle 2. You could call it angle RT, can't even read it, RTS. Or you could call it angle STR. All those would be appropriate ways of naming that. Now there is a bigger angle, angle OTS. So the big angle, the overall big angle, I'll do in red. You could name that angle OTS. Or you could name it angle STO. Either way, we don't have a number for that bigger red angle there. Okay, so the next thing, the measure of an angle. So measure of an angle, that's how big it is, how many degrees it is usually given in degrees. In trig, we learn how to do it in radians. Maybe by the end of this year, depending on how fast we go, we might end up doing that this year, but it would be at the very end. I doubt we'll get to it. Since there is a 360 degrees in a circle, 1 degree is 1 over 360 of the circle. So when you use a protractor to measure angles, you're applying the following postulate. And this is the protractor postulate. It says given, you've got a line AB, and if you look down, mine's kind of chopped off. It says given line AB, and line AB, I'm just going to use green so it'll stick out. It's right here, okay. All, and a point O, remember that's going to be where we're going to place our vertex at point O when we're measuring things. All rays that can be drawn from O can be put in a 1-to-1 correspondence with the real numbers from 0 to 180. All it means is we can read our protractor. Like if I'm reading that one, I can look at the protractor and say that looks like it's about 45 degrees. If I'm measuring this one right here that I'm kind of darkening, remember we see that there's another number there, but if we were trying to say, well, what would have, there's 45 there, but what's 135? Well, if I do this one in red, 135 would be the angle that we measure like from here to here. So if it's less than 90 degrees, you use the lower numbers. If it's greater than 90 degrees, like this red one I drew here, then you're going to use the bigger numbers. And y'all have done that in previous grades. Okay, now the types of angle, an acute angle is less than 90 degrees, a right angle is 90 degrees, an obtuse angle is greater than 90 but less than 180, and they've drawn an example there. And a straight angle is the same thing as a line, and it measures 180 degrees. And usually what happens in geometry is we're going to have like a couple of angles here. We're going to add angle 1, angle 2, and angle 3, and say that they equal 180. We're going to do that a lot this year. Okay, this is just some practice finding the measure of each angle. If you find the measure of BOA, you notice that A is kind of like, what they've done here is lined it up right here. You always want to line up one side of your angle with this bottom part of your protractor. So BOA is the same thing as AOB. So if we read that angle, that's actually the one I kind of, oh no, it's not the same one. That's actually 40 degrees. We know it's not 140 because it's not greater than 90 degrees. But that would be 40 degrees. Make sure that you see that that's what it is and you're reading it correctly. DOB, if I do that one in green, DOB is this one right here. Okay. Now, I could turn my protractor side, line up one of those sides and make it a whole lot easier, but this one's on paper, so how are we going to figure it out? Well, the side OD, the lower side, is sitting at 15 degrees, so this is 15 degrees. And then the other side of the angle, OB, is sitting at 140 degrees. So if I want to find out what angle that is, what I could do is just say 140 and then subtract out the 15. And we could say, well, that angle is 125 degrees. Normally what we would have done is turn our protractor and line up this side that I'm darkening right here as I talk. I would have lined it up straight with this part right here, and it would have made it easier to read. But we could do this if we needed to. All right, EOC, I'll write in purple so we can see this one pretty easily. EOC is the one that does this to here to here. What's nice about that one is that lower side is already lined up at 0. So all we got to do is look, where does the OC hit? it hits at, we're either going to call this 75 or we're going to call it 105. Which is it going to be? It'll be 105 because that's definitely bigger than 90 degrees. So I know I need to use the bigger number. Okay? All right, moving on. Blank are angles that have the same measure. Congruent angles. Congruent angles are angles that have the same measure. Now it says, what does this look like and how do we write it? So like let's say if I had two angles and I wanted to say they were congruent, what you usually do is this. You usually, you've got this thing right here showing that it's an angle. A lot of times that's on there anyway. We would put one mark here and one mark here to show that they're congruent. And like if this were angle 1, I'm going to write below it just because I can't fit it in the space because I wrote so small. How do we write it? I would say angle 1 is congruent to angle 2. The congruent sign means it's the same shape, same size. And it's that equal with that little tilde from Spanish on top of it. Okay. Down next, it gives us the angle addition postulate. And all the angle addition postulate is if I've got two angles and they share a side, like, okay, I've got this angle and this side, and then I got this angle, and what I notice is they share a side, right? They're next to each other. When they're next to each other like that, they're called adjacent angles, and we'll be writing that down in just a minute. But when they're sharing a side like that, if I call this one, this one is angle RSQ, I could say, well, angle R, let me write with black here, angle RSQ plus angle SQP is equal to the overall big angle. The two angles add up to the larger angle RQP. Now, I want you to notice that I just put angle RSQ plus angle SQP is equal to RQP. Your book is going to use that notation. Most books would say, they would talk about I'm going to write something in here in blue. If I can get it to pop up. The measure of that angle plus the measure of that angle is equal to the measure of that angle. The book that we use plays really loose with notations. If you notice, this measure stuff is what we've got right here going on that you can see on your paper but not so well on the iPad. Most books would say, if I add the amount of degrees there plus in the first angle plus the amount of degrees in the second angle that touches its side, it would be the total number of degrees in the whole angle. But your book plays really loose, and so you're going to see your book right. You're going to leave off the M. It means the same thing. It just means if I add each angle together, I'm going to get however big the larger angle is. Okay. And then down below it, measure of DEG is 115 degrees. So it's saying this whole angle here is 115 degrees. And they tell us that DEF, which is this small angle here, I'll label it, they tell us that one is 48 degrees. This one right here. Now they want us to find FEG. And FEG, if I highlight it, they're wanting us to find this one. Well, you would use the angle addition postulate. You would say, well, if the whole thing is 115, and I know that one piece of it is 48, I could just subtract 48 from 115, and I'd get 67 degrees. Oh, that angle there is 67 degrees. That's because 67 plus 48 is 115. So it's just like adding two pieces together to get the whole angle. And so if you're missing a piece and you know what the whole thing is, you can just subtract. The whole minus the part will give you the other part. Then there is a blank. It says, and blank is a ray that divides an angle into two congruent angles. Okay, well what goes there, and this is something you're going to be doing next week. You're going to be watching a video on how to do this and then doing it for a quiz. An angle bisector. When you bisect something, you cut it into two equal parts. So an angle bisector is a ray that comes in and cuts something exactly in half. Now that's all the time I have for this video, so I'm going to turn it off, but I'll pick up with another video and do the rest of it.